Hello, I am Matthijs from Veelen. I'm really happy to be welcome at your workshop together with Asli and Chris. So all of us are going to be talking about commitment, and all of us are from Amsterdam. So I'm going to start with an overview of why commitment is important for the evolution of morality. And I'm going to start with the prisoner's dilemma. So if you take any theory paper about the evolution of cooperation, it's always about the prisoner's dilemma. Right, so in the prisoner's dilemma there is a Nash equilibrium, which is if both players defect, and the core question then is why it would be that sometimes cooperation evolves. And the reason could be repetition or population structure, and we're going to get back to that. But the point that I hope to make now is that it's actually not super helpful to look at prisoner's dilemmas if you want to understand human morality. And for that, it's actually better to look at other games. And before talking about why that is, I first just want to go to games that are not prisoner's dilemmas. So one such game is the ultimatum game. It's also pretty famous. I'm assuming that many of you have seen it before. But just to be sure, here is how a simple version of the ultimatum game works. There's a proposer, and the proposer has €4 to divide, and she can make a proposal. And one possible proposal would be 4 for the proposer and nothing for the responder, or 3 to the proposer and 1 to the responder, 2 for both, 1 for the proposer, 3 for the responder, and 4 for the responder. Now, the responder has to have an answer ready for all of those proposals, which she can accept or reject. And if she rejects a proposal, then that means that the €4 just disappear and both get nothing. Now, a Nash equilibrium is a combination of behaviors or a combination of strategies where neither has a reason to deviate. And what you see here is an example of a Nash equilibrium. So the proposer proposes the equal split. The responder rejects the bottom 2 proposals and accepts the top 3 proposals. So in order to make sure that this is a Nash equilibrium, we can first look at the proposer. So if the proposer would deviate and make one of the bottom 2 proposals, those would be rejected by the responder, and then the proposer gets nothing instead of 2, and that's not good. And if the proposer would make one of the top proposals, she would get 0 or 1. Those would be accepted, but 0 and 1 are less than 2, so that's also not good. Now let's look at the responder for a second. If the responder would change from yes to no as a response to the equal split, then she would go from getting €2 to €0, and that's not good. And for the other proposals, for the other responses, it doesn't matter if she switches from yes to no or from no to yes, because those proposals are not made. So it is also true that the responder has no reason to deviate. Now, I would like to look at the stability of this Nash equilibrium, and I would like to focus on this part in particular, because let's assume that there is a population in which all proposers propose the equal split, and all responders respond like this. They say yes to the top 3 proposals and no to the bottom 2 proposals. Now, of course, there's always a little bit of noise. Proposers can make mistakes. So every once in a while, it's possible that a proposer makes the second proposal from the bottom. And if she does, then the responder is going to reject that. Now suppose that there's also responders around that don't reject it but also accept that proposal. Then these responders get a payoff of 1, and the responders that reject that proposal get a payoff of 0, 1 is better than 0, so there's selection pressure on responders to also accept that proposal. Now, if sufficiently many responders switch to saying yes, it becomes in the proposer's best interest to switch to making the proposal in which the proposer gets 3 and the responder gets 1. And this would be a stable Nash equilibrium because the responder is of course indifferent between accepting or rejecting the bottom proposal in which she doesn't get anything anyway. So this would also be a Nash equilibrium, but let's focus on this one. So now one could imagine, again we're focusing on this part, that if there's a responder that doesn't accept this proposal, and if the proposer would be able to tell that this is the case, then the proposer would serve his or her own best interest by proposing the equal split instead of the second proposal from the bottom. So here we're sort of going in the opposite direction, but the crucial ingredient here is that the proposer has to be able to tell that the responder is committed to rejecting this proposal. So there's two things here. Rejecting this proposal itself is bad for your fitness because you're leaving €1 on the table, but being committed to rejecting that proposal might be good for your fitness, because if the proposers can tell, they will make you proposals that are better for you, in which you get 2 instead of 1. So we call that rationally irrational. So it's irrational to leave money on the table, but there is a reason why that works to your advantage, and that's that it's getting you better proposals. Now here's another game that's not the prisoner's dilemma, and it's equally famous. So again, I'm assuming a bunch of you already know this game. It's the trust game, and we're doing a simple version where the truster has €3, and she can decide to just hold on to the €3, or she can send them over to the trustee. And if she does, then the €3 turn into €6, and then the trustee has a decision to make. So she can either just keep the €6, send 2 back and keep 4, send 4 back and keep 2, or she can send all €6 back. Now, again, we can look for stable Nash equilibria. So if we start at the trustee side, you can imagine that there's always selection to send back less, because if you send back less, you keep more. So selection will make trustees send back no money. And if trustees send back no money, then there will be selection pressure on trusters not to send any money to trustees, because if they do, they end up with nothing, and if they don't, they still have the €3. So this looks pretty stable, but also here it is possible to be irrational in a way that is actually good for you. So suppose that there is a trustee that is stupid enough or nice enough to be committed to send back 4 out of the €6 here. And suppose that the truster can tell. So suppose that the truster can tell the difference between trustees that are not going to send back money and trustees that are going to send back money. So in that case, the trustee that will send back money will receive money. So in that case, it's in the truster's own best interest to send the money over. And so that means that sending back money itself is not good for your fitness, because then you end up with 2 instead of 6. but being committed to sending back money is good for your fitness. Because if you weren't committed, the truster isn't going to send money over in the first place, and then you have nothing. And if you are committed, then the truster will send money over, and then you end up with 2 instead of 0. And again, it's of crucial importance that the truster can tell. So the recurrent thing here is that that commitment can work, and that irrational or rationally irrational behavior can evolve, because there's behavior that itself is bad for your fitness, but being committed to it has an effect on what other people do, and that effect can be good for your fitness. Now, this is not something that we just came up with. There's a book by Robert Frank from 1988, so it's has been around for a while, that makes exactly this argument. So his idea is that the reasons behind a bunch of emotions is that they are strategic and that they change the behavior of other people. And I find it kind of surprising that this idea plays such a small role in the literature on the evolution of morality and deviations from selfishness. So if you look at the literature on the evolution of cooperation, it focuses on a few mechanisms. One important category is population structure, so this would be group selection or networks or a whole bunch of things. So also kin selection, so many of those would also fall under kin selection. There's a lot of papers about repetition, and there's also a bunch of papers about partner choice. Now here, it's important to realize that partner choice can be part of commitment. So if you're playing the trust game and the trustee can choose between the truster can choose between 2 trustees, and one of them is just selfish and is not going to send any money back, but the other one is crazy enough to send money back, then the truster will choose the crazy trustee who is nice enough to send money back. So partner choice can be part of commitment. And most papers about these first 2 focus on prisoners' dilemmas. Now, for us, it's interesting to look at how well these first 2 categories do in explaining human morality or human cooperation. And there's 2 things that you can look at. You can look at the behavior itself and ask how well the predictions from those models from categories 1 and 2 match the behavior that we see. And you can also look at different species and ask yourself the differences between population structure, between humans and, for instance, other primates. Do they match the differences in behavior? And it turns out that for both of them, the answer is that they don't match very well. Now, Asli and I have a paper that's almost done that is going over a lot of the empirical evidence. So half an hour is, of course, way too short to discuss all of those, so I'm just going to focus on a few aspects here. So population structure models can sometimes be explicitly genetic. They can also be explicitly cultural, so transmission can be genetic or cultural. And there's also models that allow for both interpretations. Now, if cooperation evolves because of population structure and transmission is genetic, then you need a positive relatedness. And this is something that we're not the first to notice, right? Almost every paper about the evolution of cooperation starts with the observation that we are also nice to genetically unrelated others. So that would be at odds with a population structure model where transmission is genetic. Now here's an observation that is a bit less frequently made, and that is that if transmission is cultural, what you need is that players or individuals have a limited understanding of the game, and that is a little bit at odds with how humans compare to other species, because we are actually really, really good at understanding games. So I want to illustrate that with an example. So here is a population structure. It's a circle, and the red dots are defectors and the blue dots are cooperators. And all of them play two prisoners' dilemmas, one with their neighbor on the left-hand side and one with their neighbor on the right-hand side. And that means that these guys that are surrounded by defectors are getting a payoff of 0 because they get 0 from their interaction with their left neighbor and 0 from the interaction with their right neighbor. Then there's two defectors that have one blue neighbor and one red neighbor, so they get a payoff of 0 from the red neighbor and a payoff of 3 from the interaction with their blue neighbor. Then there's two cooperators on the boundary. They get -1 from interacting with their defector neighbor and +2 from interacting with their cooperator neighbor, and that adds up to 1. And then there's a bunch of cooperators that get 2 from the left and 2 from the right, and therefore they get a payoff of 4. Now suppose that we have cultural transmission, and this individual gets the opportunity to update her strategy. She can look to the left, and she can look to the right, and then she would see that the person on the right, who is a cooperator, has a payoff that's higher than the payoff of the defector, and therefore she could choose to imitate this individual with a higher payoff. Now if she does, then her own payoff change from 3 to 1. So in order for this to work, what has to be true is that this player doesn't understand that switching from defection to cooperation actually is going to cost her 2. And if you do understand that that's the consequence of your change in action, then this is not happening. So genetic explanations with population structure don't really match the empirical evidence, because we're also nice to genetically unrelated others. But also cultural transmission in combination with population structure doesn't really work, because if you compare humans with other species, we're actually the best on Earth at understanding games and theory of mind and understanding incentives. I'm going to jump over this. So, well, there's a bunch of other things. If you would be interested, we're totally happy to send the paper with everything in it. So what I want to do now is try to illustrate that there's a whole bunch of other games that are also of interest for the evolution of human morality and cooperation. And this is one that we came up with, so we don't know what to call it yet. You could call it the insurance game or the friendship game. And here's how it works. There's two individuals, and it could be that one of them is lucky and gets 3 and the other one gets 0. But it could also be that the other one is lucky and gets 3 and the one gets 0. Now the lucky one can choose to just keep the 3, or can choose to share, and then the idea is that if you have almost nothing, then getting something is much more valuable than it is costly to the person who has a lot to share. So if the lucky person shares, then both end up with a payoff or a fitness of 2. And that goes, of course, also for the mirror image. The lucky one can choose between keeping everything and sharing. Now also here, commitment could evolve. So if you happen to be the lucky one, it's of course bad for your fitness to share. But if both individuals can commit to sharing, that would be good for them, because that means that they can get a guaranteed payoff of 2, which is better than a 50% chance on a payoff of 3 and a 50% chance on a payoff of 0, which is what they get if both of them don't share. So this would help understand why people become friends and why people care for each other. So you could imagine that in a game like this, there's a selective pressure on willingness to share, or in other words, in caring for the other, because then you would be chosen to be friends and care for each other, and that would have to go in combination with a good sense or the ability to tell who genuinely cares and who doesn't genuinely care. So something that you could explain with this game is what we would call hypothetical reciprocity. So normal reciprocity works like you scratch my back, I scratch yours. So I'm going to do something nice to you if you have done something nice to me. But what people also regularly say is, you would have done the same for me. And you cannot get that from models with normal reciprocity, but you can for this one. So if we go back to the overview of mechanisms for the evolution of cooperation or altruism or morality, there is a large category population structure, there's a large category of repetition, and we're not saying that these don't matter, but we do say that commitment is also really important, and commitment can work because it influences the behavior of your existing partners, but it can also work because it makes you more attractive as a partner, so it makes you be chosen as a partner. And there's a whole bunch of things that you can understand with commitment that you cannot understand without commitment. So Asli and Chris are going to talk about 2 examples of that. So honesty and conditional cooperation. So I would think that human morality does not make sense except in the light of commitment.